Welcome, everyone. We're going to get started now. Thank you for all joining us for this really exciting first episode, so to speak, of this webinar series on gateway platforms. So I'm just going to give you a few housekeeping pieces of information. We would prefer that you keep your audio muted and your video. We're going to be recording this, so we'd like to keep the sound as clean as possible, as well as the video. And then shortly, you'll be able to see our presenters on video as well. You can submit questions on chat at any time, and I will be saving them until the end to share with our presenters. And I mean, unless it looks like it's like an absolute crisis kind of question, you don't understand something, but otherwise, just submit a question through chat and we will share it with them towards the end of their main part of the presentation. This recording and the slides will be put on our website, on sciencegateways.org. So I just want to talk a little bit about the Science Gateways Community Institute, which a number of you probably know plenty about because I see some familiar names on our attendee list. But the Science Gateways Community Institute has been funded by the National Science Foundation to provide a variety of support functions and community building activities to bring together the Gateways community. The first of those areas is support for building and running gateways. We not only provide consultants who can do hands-on development, as well as provide advice on various topics that are very specific to gateways, such as cybersecurity and sustainability, but we also have a catalog where gateways can promote their own products and projects, as well as find software that, such as this item in our series, to use to build gateways. The second area that we provide support is through education and training. Obviously, this webinar series is one of those. We also have Gateway Focus Week, which is coming up for 2020. It will be in June and the very end of November, beginning of December. One will be in New York, and then other will be in San Diego. That's the November-December one, so keep your thoughts on that one. We also run a variety of student-focused programs, an annual conference, and our website has a number of resources available. And then our third main area of support is by providing a broader community and more organized community with ways of connecting with partners. Our affiliates are folks who are in the catalog of software who are willing to support that software to members who reach out to them, either through us or directly. We have a variety of news outlets, including a blog. We welcome guest posts, which we do now and then, but feel free to contact us if you'd like to do a guest blog post. We also have a forum, Google group that you can join to pose questions and engage with others, and obviously the conference is a great way to connect with others. So all of those come together on our website. To get more information, that's where you should go. And with that, I'll just make one last request, which is if you can take a moment, I will put this link in the chat section when we get closer to the end or middle of our webinar. We just love getting your feedback. Most of it is just to ask whether this was valuable for you, but also there is an open-ended question which lets you make suggestions for future topics. And this series actually came out of someone posting in there that they would like to hear about different kinds of gateway platforms. So we do listen, and we look forward to hearing from you. So with that, I'm going to stop sharing my screen, and I'm going to hand this off to our presenters who are joining us from the Texas Advanced Computing Center. Also, Julia is part of the Science Gateways Community Institute development team. And I'm just really excited that Julia and Rich were willing to kick off this series about platforms for gateway development as our first speaker. So I'll hand it off to you guys.
Thanks. Yeah. So, as Catherine said, we are Julia and Rich from the Texas Advanced Computing Center, and Today we are going to talk to you all about Tapas, which we think is really great for building gateways and many other things. So a lot of you probably know us. We're TAC. We're a supercomputing center, and we have a lot of big machines. You can see some of them in pictures right here. And we try to solve a bunch of different challenges with these resources that we have. Some of them listed here, such as instruments and sensors, data processing, model simulation, sharing and publishing, and some, quite a few other things as well. So one thing that we created to help with some of these challenges is the Tapas project. And so in general, it's kind of just a framework to support computational research and enable researchers to leverage computing resources across various institutions. And so at a more technical level, it's a set of REST APIs, language SDKs, and CLI for managing data and executing code on our various different platforms, such as HPC, HDC, and in cloud. So why would you want to use Tapas? Well, you could use it for solving many of the challenges that I mentioned before. And you have the ability to track your analysis and reproduce your analysis and share workflows and that sort of thing. And here is an example of some people who are currently using Tapas. We are in the process of adding more collaborators. But down to what you all are probably interested in is, how does this relate to gateways? So Tapas can be used to help create gateways and do cool things with them. One example that we have at TAC is this design safe gateway. And so we have a web page front end for this gateway, and it integrates a lot of Tapas concepts. So for instance, the login leverages the Tapas OAuth system and using the TAC LDAP. And then we also have a few applications available to the users in the gateway, such as the data depot, which uses the systems, files, and metadata parts of Tapas. And it also leverages systems, apps, and jobs, and that sort of thing, so that you can run jobs using Tapas. And one kind of example of this is being able to launch a OpenSeas job via your browser. So essentially, on your gateway website, you can just have like a web form, and then using Tapas, that can translate into an actual like OpenSeas job that gets sent to some kind of HPC resource.
Okay, so this is Rich. I'll go through the next few slides with you. So Tapas currently runs in production. We call it version 2 of Tapas. It's previously known as Agave, and it implements the concepts and resources, of systems, files, applications, and jobs. And these allow us to manage and share data and to run jobs on both on cloud systems and on HPC systems.
We're not hearing any sound at the moment. I'm not anyway. Anybody else not hearing sound?
Oh, I'm sorry.
Sorry, we accidentally clicked the wrong thing.
Yep.
Okay.
Can you hear me now?
I can hear you now. Yep.
No, that was us. Sorry about that.
Okay.
As a matter of fact.
Thank goodness.
Yes, it's quite a jerry-rigged kind of thing here. Anyway, I guess you guys could read. It wasn't too much to read. So, we have these system concepts, and we have metadata that allows us to associate JSON documents with the Tapas resources. We have an actor-based function execution engine that allows for event-driven functions to be usually short-lived functions to be run. And we have an authentication module that allows tenant-specific user authentication to be implemented in a gateway, so that for each tenant, the authorization request for when a user logs in can be routed to the tenant's specific LDAP or any other backend that they use for authentication. Tapas version 3, that's the future version, the version we're currently working on. And it has many of the same concepts as in version 2. So there are systems, files, apps, and jobs as in version 2. It has a metadata service, and it has the OAuth 2 authentication module. But all those are being completely rewritten, and they're not only their code, but their logical design is also changing. The actor-based Abaco functions are going to be evolved, so we're basically using the same code base there. So in addition to doing a lot of rewriting and rethinking of existing capabilities, we're introducing some new capabilities. And the first thing is that we have first-class support for containers. All applications that are going to run in the version 3 will be run from images in containers. We'll be supporting Docker and Singularity to begin with. We'll also have to store and process sensor data in real time through a Streams API. And we are going to decentralize our secrets store, and we're going to implement the secret store that's decentralized, and it provides also for an authorization subsystem. So the goals of version 3 are to use containers to maximize job portability and reproducibility. As I mentioned, all applications are going to be delivered as images that run in containers, Docker or Singularity to begin with. And the idea here is that we want to improve portability by extending our systems model to have this idea of capabilities that a system has, and applications would specify the requirements that they need in the system that they are going to run on, and therefore we'd be able to move an application around to different systems that meet the application's needs. Today in version 2, applications are hard-coded to a specific system. So this is an important improvement over v2. And the second thing is that we hope to improve reproducibility by using images and containers so that many of the dependencies at runtime are actually already in the image, so there's no problem of finding them. Our goal is to support sensor input and streaming data. This will allow us to have real-time event-driven workflows. We're using the Chords time series data facility and integrating that with our actor and job computational engines. And finally, we want to extend version 2 more properly to multiple data centers on multiple sites. So the idea is that we'll have one primary site in any given Tapas installation. Anybody can still run their own Tapas if they like, but in any given Tapas installation, you have one primary site and 0 or more associate sites to run Tapas components. The decentralized authorization and secrets access will be implemented by allowing multiple security kernels to run in the system, some on associate sites and on the primary site. And let's see. Yeah, so the idea is that we're going to be able to isolate authentication, authorization, and secrets management by tenant. And we'll see where that comes in a slide or two. So here's an architectural overview, a very simplified version of the version 3 architecture. You can see on the top left, there's the primary site, and it contains a router that gets incoming REST calls and sends them to the correct Tapas API or service that you see there in the orange boxes. The security kernel, SK, is actually one of the services. The primary site has all the databases and persistent queues in the system. And the other sites, known as associate sites, are on the right and at the bottom. If we look at the bottom one, we see that an associate site has a router of its own, and it has Tapas agents, which are pieces of the Tapas services that can run. It can also have a security kernel of its own, and it may have computational and storage systems available. If we go through this quick workflow, this kind of simplified workflow, assuming a user has already authenticated. If you look on the bottom right, you'll see a user makes a request in step one. It goes to the router in at their local site. That router may forward the request to the primary site. In this case, it does in step two. Step three, the request is processed by one of the services on the primary site. And in this example, a work request is placed on a queue. Step four shows that the associate site agent picks the request up off the queue. And in step five, it uses the local security kernel to authorize the request and to acquire any secrets it needs to, in this case, access storage locally. So there are two main things here that improve upon what is available in version 2 of Tapas, the current version. One is that we are running parts of our code. We can run parts of our code on external systems, not external, on associate sites, and these agents that run there, they really function as we're able to bring the computation to where the data is. So in version 2, we had to move the data to wherever the computation is. In version 3, we can move the data or we can move the computation. The other thing that's new here is that the security kernel can be housed at the associate site so that secrets and authorization as well as authentication is all done at the associate sites, which is a requirement for some of our users. They have institutional policies that say passwords and security keys cannot move off the site. So there are challenges that we're facing with the multi-data center approach. The first is security. We have to establish trust between geographically dispersed services. Yet we have to allow local administration of the secrets and permissions as well as secrets and permissions. Another challenge is configuring the system. We have to determine what components will run at each site, and we have to route requests and work to the proper service instance at any moment. And finally, there's management of this. It's an order of magnitude more complex. The sites themselves may use an orchestrator such as Kubernetes to start up their services, and we have to integrate all that into a working system. We will have to deal with coordinating updates and maintenance, starting and stopping services, monitoring, logging, auditing, and debugging a more distributed system than we had in version 2. So just to describe the security kernel a little more, on the right-hand side, we have a security library. The requests come in from the right, not shown, but they would come in from the right. They're REST requests coming in from our users or our clients, the security kernel clients, which will only be other services in Tapas. And security kernel itself has two persistent backends. One is a HashiCorp Vault cluster, which can be run in HA mode, but doesn't have to be. And that's a secret store. And on the bottom is our implementation or extended implementation of the Apache Shiro authorization engine that does permission checking. And it'll have a database, a Postgres database that it stores its permissions in, and the server will cache, any cache permissions on an as-needed basis. So that's what a security kernel looks like. It's a fairly complicated thing because it has it provides one interface, but to two persistent stores. So the challenges here are to make sure that we have fast, fine-grained authorization checking available to us. We extend Apache Shiro permission model a little bit to help with that by adding a little flexibility. We use a Postgres backend and server caching. So far, we haven't seen any problems with the amount of time it takes to get authorization requests back and forth, but we'll be keeping an eye on that. Another challenge would be to have comprehensive secrets management. I mentioned we use HashiCorp Vault as a backend. It's an open source piece of software. All non-user secrets used by the system are kept in the vault. Non-user meaning when a user logs in, they go through the OAuth 2 agent, and so that's separate and already managed in V2 by each tenant, and that'll continue. But the vault will contain SSH keys, DB credentials, any type of password that are used by the system to access storage and computational resources. The idea here is to be able to automate things like key rotation, simplify key distribution using Vault certificate authority. So it's kind of a comprehensive solution that not only how do you get secrets and how to initialize secrets, but how do you manage them over time? And the final challenge here is the portable deployment. Each tenant can have his own security kernel instance. Ease of deployment is paramount. It has two complicated backends that it uses. So these things have to be basically turnkey. So we have to manage that. And we have to provide ways for site administrators to manage their security kernel, especially in the cases where policy at that tenant is that secrets never leave the site. Another challenge is that we're trying to do smart scheduling. So as I mentioned, all the apps are really just images that run. That's Docker or Singularity. We extend our systems definition to advertise their hardware and software capabilities, the different kinds of use or specialized hardware they have, the versions of various libraries, the operating system, everything that can describe a system that's important to applications can be added to their capabilities. And then we can schedule workloads to run on qualified systems that qualify for a given application. The goal is that we can take dynamic resource availability into account to minimize time to solution for any given application. So we'll take into account, for instance, queue length that is at the moment on a given system, and try to make a smart decision about where to run an app. So the challenges here, dealing with containers, is to make sure that we can encapsulate most of the dependencies of a container in its image. Another challenge is to enable greater portability. Is to have our matching algorithm be dynamic, as I just mentioned, so to minimize time to solution. And finally, we want to make sure that image distribution on a multi-node clusters is efficient. We don't want a lot of data moving around a cluster before we can even start running an application. I think that's it for me. I'll pass this back to Julia.
Okay, so as Rich mentioned in one of the previous slides, we have a functions as a service API called Abaco that sorry, I'm having a hard time to something out, but I cannot.
Can't get rid of that.
Oh, there we go. Okay, sorry about that. So the way that this works is users will define something, a function that they want to run in a Docker image. And then using the Abaco API, they can submit that, and it gets created. It gets that user gets an actor, and so the actor will assign a unique URL that over which it can receive messages, and so then the user can simply send the actor a message via HTTP post request to the URL, and it will launch a container with the image that the user provided, and it will inject the message into the container. And so this can allow the user to essentially, run whatever can be in a Docker image over Abaco. And so some additional challenges that we've been trying to solve are real-time complex workflows. So things like events that can trigger workflow processing and then getting results from steps throughout the workflow, and mixing real-time, batch, cloud, HPC resources, that sort of thing. And one of the things that we've developed for this is the Streams API. And so this particular project integrates with chords, as Rich mentioned earlier. And so essentially there's data that's constantly streaming from geo-distributed sensors. And so the Streams API can help trigger data processing or workflows based on conditions that the user provides. And so it can help with real-time data processing, and it can also do things like invoke notifications in jobs. And this is done primarily using InfluxDB, MongoDB with a backend REST interface. So this is one thing we're using to help solve some of those challenges. So as far as the Tapas roadmap goes, right now we have a V2, our V2 version in production. It's currently being used by quite a few people, and our V3 is still currently in development, and this is the one that we just got our grant for back in September. And our early adopters program started this year, and we plan for a beta release in the early summer. And we also plan on doing some early adopter workshops sometime this year, probably in the summer. And that being said, we'll also be providing various trainings and tutorials throughout the year. And you can check this link here. It's not up to date right now, but we will be updating it with some of our future trainings for this year. So if you are interested in learning more about Tapas or wondering how you could use it, how it could help you, feel free to join our Slack team there at the bottom. You can see that, or you can check out our docs or our webpage. So thank you all for listening.
Terrific. That was very efficient and very technical. So I have to say I don't have a lot to ask, but there were some questions that popped up, and you'll be happy to know that Sean Cleveland actually was answering some of them for you.
Thank you, Sean.
Yeah, I know. Yeah, but I'm going to reframe, put a few of them back on here just in case, on the table for answering, just in case he did not fully answer it or like you want to add something to it. So for example, one question came from Mona, who's asking whether Tapas is using Java, and Sean said that some of the microservices APIs are implemented in Java and some in Python. Is there anything you wanted to add to that?
No, that's pretty accurate.
Oh, okay. Nothing else to say. All right. And then, and then I guess it also says the deployment of the components is in Kubernetes containers. You could use the same cluster, oh, well, sorry, so maybe that's an answer to this question. So it says, can these different sites be in the same container or must they be separate? And I think that this is the answer to the question, which is currently the deployment of components is in Kubernetes containers. You could use the same Kubernetes cluster to host multiple sites by configuring the API router to route the correct instances, but this might be better for Rich or Julia to explain in more detail. So there you have it.
Yeah, I'm not sure if, I'm not an expert in the Kubernetes part of this yet. It's still coming about, but you could, so everything is being, all the services and all the databases and everything are being run as containers. So Kubernetes can orchestrate all that. The actual having a Kubernetes span multiple data centers is possible. I don't know what the current state of the art is on that. We were probably going to start taking baby steps first and have the different sites use different Kubernetes. So if you had an associate site, it would, we would know what we want to run there, and you could run it using Kubernetes. But it would probably be a different Kubernetes instance cluster than the one at the primary site. I think I'm just under the impression that that's typically the way people go with Kubernetes is, you have Kubernetes run something in one data center, but once you start putting multiple data centers under the same Kubernetes, things start getting a little complicated. So that's my take on it. Like I say, I'm not an expert on Kubernetes yet.
So Rich, I think people also wanted a definition of tenants, and I think maybe the question might have been related to, can I have if I have multiple tenants, do they have to be in, separate separate containers?
No. So
we might want to define a tenant better.
Yes, we didn't define it at all. So yes, so a tenant is you can think of it as a group of users. Typically, it's an organization of some sort. Like Design Safe is people involved with engineering natural hazards. Cyverse is for the biology community. So basically, you can think of a tenant a little bit more technically as the group of users that use the same authentication mechanism to sign on. So they might use the LDAP. At a certain their own LDAP. So that's a tenant. So a tenant is a logical business unit or group of users. The services that run are all multi-tenant enabled. So the same system service or job service can handle multiple tenants. So the actual code that we write is a multi-tenant code, but so that's one option. So we don't need a separate system service for every one of the tenants. You can always split a tenant off to have its own service, and this would make sense with associate sites. An associate site might be, have its own data center. It has one group of people that it services, and it might make sense to have some of the services run there. Just for that tenant, but that's not required.
Hi, this is Mona. Can I add to you?
Yes.
Okay. So a tenant then would be one science gateway. We could think of it. If we run our own science gateway without any other science gateway, then it's a fairly simple one tenant system. Even though this can handle a multi-tenant setup. Now, I guess my question with the container is, if I have just a simple science gateway, just one, can I run all that's necessary in one container, or do I need to separate the different components out into different containers, which then will require the Kubernetes?
Okay, so if you're writing you're perfectly right about saying you have, typically a tenant is a science gateway. That's almost one-to-one, that would be the norm. So you would have your science gateway, and you would have your code written in whatever language you want, delivered in whatever language you want, and deployed any way you want. You could use anything, COBOL, anything. The only thing that you do to interact with Tapas is that you issue REST calls, HTTPS calls. So your whole interface is to some place where Tapas is running. For you, it shouldn't matter. As a software developer, you would just say Tapas is going to be running somewhere, and here's the URL to get to it. And that's all I need to know. People who might implement the back end of your Science Gateway may be interested in running their own Tapas locally for security reasons or performance reasons. For instance, Sean runs his own version of version 2 of Tapas, at the University of Hawaii, because we found that it was prohibitive in data transfers were prohibitively slow. So just run a whole version of Tapas over there. So now, did that answer your question? So you don't actually run any part of Tapas as a Science Gateway, as a front end. You simply use us as a bunch of web services.
Okay.
Right. And so you can implement your code in anything you want and deploy it any way you want.
Okay. And then in terms of the Kubernetes and containers, if you do your own Tapas service, like what Sean does, then can it be all in one container? That's my understanding, it does not require Kubernetes to sort of manage that then? Or does it need to be in separate containers, which then will require Kubernetes?
So each service is in its own container. You don't get a choice on that. But how you run those, for instance, version 2 has a bunch of containers running in various places, and we don't use Kubernetes in version 2. So Kubernetes is really optional. That's just a modern approach to the DevOps way of scaling up containers. But for instance, here at TAC, we run our version 2 of Tapas, and we don't use Kubernetes at all. We do Docker start and Docker stop, and we use Docker Compose to start up containers.
Okay, thank you very much.
Okay.
All right, I'm going to pose another question here that came in. Let's see here. Next one. Sorry. Rajesh asked a question, which is, are workflows first-class objects, or do they need to be strung together using Abaco functions? Does that make sense?
Okay, if I'm understanding the question correctly, please stop me if I'm not. So, I think for using Abaco, it's typically like, okay, I have one kind of script or function that I want to run. And so, I think in terms of like workflows, like you could fit Abaco into your workflow if you want, for various parts. Is this kind of along the lines of your question?
Yeah, and I think there was a related question by Patrick as well as to how it relates to existing, I guess, workflow systems like Pegasus and others.
Gotcha.
So Abaco itself is not a workflow system. You don't define workflows. It's an actor-based function execution engine. But for instance, we do have a user that does use Pegasus, and it ends up calling. I'm not sure if it calls Abaco, but it certainly calls the regular jobs batch service. It's Tapas jobs. So it is not you do not define workflows.
Right. Yeah.
Okay, but if you did have to, then is there a way for you to say create your own workflow ID and sort of use that to, or put that in like your JSON that's being shared as events to your Abaco functions, and then sort of string them along that way with like a common ID or something?
There is, and there is a way in Abaco to kind of like, when this function is done running, then do this one. Like there's ways of like
chaining them together.
Kind of chaining them together there.
Yeah. I think Abaco I mean, basically you send messages to actors,
Right.
right? So,
And it uses a queue.
right, it uses a queue. So one function ends, it can send messages to one or more other actors, and then they
Right.
can continue. So it's kind of like, passing the baton kind of way of
Right.
going.
Yeah. Totally.
Okay, and can you sort of leverage the provenance tracking as well to sort of add your own, I guess, metadata to make sure that you know what the steps were in a particular sequence of execution?
Yeah. So you can, Abaco, it does give you obviously like results about the execution, but you can also add additional things to your actor, like certain variables and stuff that you want to be like passed along or whatever.
You can parameterize
Yeah.
completely.
And then you can like, I don't know if this is implemented in our production environment yet, but we're coming up with a way so that like we can have a group of actors and say, okay, these particular configs are available to all these actors in this group, essentially, to kind of help.
So they can share data?
They can share data amongst each other.
Okay, great. Thank you so much.
Yeah.
So the related question that was from Patrick, and might also be, there's also a question from Carol that might also be related to what you just were talking about. So Patrick asked, can you explain how you intend, maybe Patrick did get an answer, but I'll say, can you explain how you intend Tapas to work with or use instead of workflow management systems? So is there any more that you wanted to add to that?
Yeah, I think Tapas presents itself as a bunch of web services. So as long as existing workflow system can make, web service calls, they can call Tapas. We don't have any plan to actually make it into, to have our own kind of workflows and become a workflow system. I think we kind of drew the line there as not becoming a workflow system.
Okay. And then I guess the other somewhat related question that I think Rajesh sort of asked when he was talking on the call was Carol's question. I'm also interested in hearing more about provenance tracking. What info is tracked, for example, info on the job submission form? I don't know if that was fully answered.
Probably not. Certainly not. Yeah. So I mean, we already do this in version 2, the production version of Tapas. And that's been out there for years. So you can present. So when you define systems, you define applications, and you define jobs. The jobs have parameters, runtime parameters, and runtime input files that get staged to the proper place for the execution system to get to them. So all those things. So the files that come in and the parameters that get passed can all be archived with the results of job execution. So any result that the job wants to save itself, which means the user's application, any kind of providential information that can be saved by the application as part of its output, and then all that can get archived. So what we're going to try to, in version 3, the idea would be to take it a bit further, because the actual code that runs, a lot of it could be in the container. So the actual version, the libraries at the versions that ran are in the image. So hopefully there'll be even more automatic kind of documenting of what happened and how things ran. I don't know if we could ever get to 100%, given that you have to get down to the level of what versions of chips are being used, possibly, if you wanted to get absolutely precise about things. But anything that the application wants to store can be archived as part of its results, and all the inputs and parameters passed into are already done. And if you have that plus the image and the version of the operating systems and Docker that you were using, let's say, you have a pretty good chance of being able to get the exact same results. Probably not perfect, but pretty good.
Great. And there's another question that came from Jack with a +1 from Mona about can it leverage in common or Globus auth for federated AIM?
Yes, is the simple answer. Let's see. So that's actually that's the authentication server. We're rewriting that completely. We were using a third-party one for Tapas version 2, but we've decided to write one of our own for the version 3.
Yep.
And LDAP is the first backend that our authentication server would talk to and be configured. Figure with that's one of the most obvious paths. But whether it can use in common or Globus or any of a number of your Google accounts or your AWS credentials, any of those kind of things, we're doing them on as they come up, we can add them in. I'm not sure what the plans are exactly for that at the moment.
I think that's pretty much the plan.
Yeah.
Yeah.
Take it as it comes.
Right.
But the idea is that sure, credentials can be stored in a lot of different ways. You could use GitHub credentials or your, like I said, Google accounts, and it would probably be useful to be able to get to those also.
Terrific, thanks. So there haven't been any other questions that have come in through chat, but I do have a question that might be a helpful context setter for others who might listen to this later on or who don't know you, because I imagine some of the people on the call know you. So Tapas, it sounded like from what you said at the beginning that it's been used for design safe. And so I guess my question is this a generalized, did you create the design safe platform, which I know has been running for a little while, and then generalize it so that it could be a broader platform? Or is this an evolution from another project that is at TAC? Does it have a longer history than that even? Because I don't feel like I had heard of Tapas prior to very recently, or fairly recently, and I just wondered if it's sort of like the next evolutionary step of something that has been percolating and developing at TAC for some time.
Yeah, it has been percolating, and I guess there are three major phases of this, and I haven't been here for much of it, so for me it's somewhat folklore for me. But this middleware started out in the iPlant project, which was, I think, with the University of Arizona. It was, and it's really and that project itself has mutated into Cyverse. So the first version of our layer, of our middleware layer was iPlant. I believe that started around 2010, maybe. I can't be quoted on this. There are people who do know, but I'm not one of them. But that was the first version. And then after the experience they gained with providing the middleware for a gateway for the biologist community, plant biologists in that case, they said, hey, we can generalize this and make it more of a general middleware layer. So that was the version 2 that's currently in production. That, I believe, started in like 2012 or 13, and it was a 5-year NSF award it was called Agave at the time. So
okay.
So Agave is, Tapas, this is the lineage. And then the version 3 now is from an award from 3 months ago. So, and it's a 5-year award. And it's done with partners. So the University of Hawaii and TAC are partners on version 3. Version 2 had, I believe, LSU and TAC and maybe the University of Hawaii also. I believe so. I could be wrong. Sean would know. So there have been collaborators along the way, various collaborators, but these are, it comes from a lineage that's probably about 10 years old.
Okay, yeah, that's helpful because I knew that the grant was fairly new, and I wondered because obviously you couldn't be on version 2 and heading into version 3 if it only just started 3 months
If we
ago.
were honest.
So
Right.
I'd be really impressed otherwise. But so another question has come in while you were chatting. Rajesh asks, will Tapas be integrated with Exceed systems to support job submissions to those systems?
That's a good question. We currently are. I forget exactly how that works, though. It's not an area I know much about. So
I think Sean might have put something in the chat.
yeah.
Yes, Sean just said we have discussed system templates to make it easier to create systems in Tapas. So, for example, Exceed templates.
Okay.
But yeah,
Yeah.
does that answer it? Yeah, I don't know. Yep, it looks like it did. Okay, fantastic. All right, we have a few more minutes left. If there are other questions that people have, you can put them in chat.
And I do want to just go ahead and remind everyone, if we did not answer your question adequately, or if you have more questions, feel free to join our Slack there at the bottom link, and we'll be happy to continue any kind of discussions there.
And we'll put we can put these 3 or 4 more information links. In addition to posting the slides, we could put those up on our posting of this recording on the website too. So
Oh, great.
have it handy. Yeah, we can do that. So yeah, so let's see here. So I guess, yeah, there are no more questions coming in. What I'll do is I'll take a moment just to tell folks about our upcoming webinar next month, and then if more questions come in while I talk about that, we'll add that to the fire. How does that sound? So so I'm just going to take a moment and oops.
Do we not share?
Do we need to unshare?
Yeah. No, actually, I think I can boot you off and grab.
Okay, good.
Yeah. Yeah. Let's see. Oh, here we go. Let's see.
There we go. Okay.
Yeah. So yeah. So I need to put this link in so you guys can give us feedback. As I mentioned, I would do. I've just been so absorbed with all these questions, I haven't thought about that. Our next webinar will be February 12th, which is also the second Wednesday of the month. It's going to be our the professor who oversees SGCI's usability consulting, Paul Parsons, and he has been working with a number of different projects over the last couple of years. So he's going to talk about lessons learned from that. I think it'll be really a valuable opportunity to hear about how usability has been addressed with various projects that might have things in common with whatever gateway you're working on, meaning you globally, all of you listening to this. So, so I hope you'll join us for that. If you don't already get our newsletter, sign up for the newsletter and you'll be notified when that's coming along. And I think that's it for that. So let me just see, oh goodness gracious, if there's any other questions that have come in the last moment or two. It looks like not. So I guess with that, maybe what we'll do is we'll end a couple minutes early, but I'll thank all of you for, the two of you rather, I should say, plus Sean, for joining us today. Yeah, I'm gonna stop sharing so I can actually copy this link and encourage folks to give us feedback. Oh, another question came in. Woohoo! Let's go for it. So okay. I will share that with you. So you have 4 minutes to answer this question, which is from Jack. He says, is TAC Cloud the same as Tapas in Slack?
Yes. When you join our Slack, it will say TAC Cloud, but that is our Tapas Slack. Right.
Yeah. Well, Tapas is the actual, one actual project, whereas TAC Cloud is generally more of any cloud offering from TAC.
Right.
Though Tapas is the main one at the moment.
Right.
Great. All right. Yeah. So, okay. So it sounds like you already have a new subscriber.
Yay.
So yay. So yeah, anyway, Julie and Rich, thank you so much for presenting today. This was really helpful, I think, for
Yeah,
a lot of folks. And Sean, thank you also for fielding all those questions on the chat.
great.
So thank you
Yeah.
so much, everyone.
Yeah, thanks for having us.
Yes, thank you.